You know, if you're like me, you probably think of Dropbox as just that magic folder on your computer. You drop a file in, and poof, it just shows up everywhere else. It seems so simple, right? Well, it turns out that behind that beautiful simplicity is an absolutely staggering world of engineering that we're going to pull back the curtain on.
I mean, have you ever really stopped to think about it? That one little moment, the instant you hit save? What kind of incredible, complex chain of events does that one action kick off? I'll tell you what, it's way more fascinating than you could ever imagine.
So that's exactly what we're going to do today. We're going to follow a single file. We'll trace its entire path from your keyboard to the cloud through this amazing labyrinth of custom-built software, custom-built hardware, and some seriously clever ideas. Let's get started.
All right, so our file's epic journey begins in a familiar place, right there on your own machine. The very first piece of this whole puzzle is the Dropbox client. Think of it as this incredibly smart, powerful guardian that lives on your computer, and its only job is to watch your files with an eagle eye. Now, for more than a decade, this guardian was powered by something they called Sync Engine Classic. It was written in Python, and over time it just got, well, chaotic. It was prone to these bizarre bugs they called Heisenberg bugs. And if you're a developer, you know what I mean. These are the kinds of bugs that literally disappear the moment you try to observe them. So to fix this for good, Dropbox did a total rewrite in Rust, creating Nucleus. The big idea here is that Nucleus is deterministic. That's a fancy way of saying for any set of actions, the outcome is always the same. It's predictable. And that one change wiped out an entire class of impossible bugs, making the sync process rock solid. So how does Nucleus actually achieve this perfect certainty? Well, it uses this really elegant three-tree data model. The best way to think about it is like a constant three-way fact check. First, you've got the remote tree. That's the source of truth according to the Dropbox servers. It's what should be on your computer. Then there's the local tree. That's the ground truth, the reality of what's actually on your hard drive. And finally, the sync tree. You can think of that as the last snapshot when everyone was in perfect agreement. By constantly comparing these three, Nucleus knows instantly and without any doubt exactly what to do. Upload your new stuff, download changes from the server, or if both have changed, it just creates a conflicted copy. No data is ever lost. It's kind of the secret sauce to perfect syncing. Okay, so Nucleus has spotted our new file, it's been chopped up, encrypted, and it is ready to roll. Now it leaves the safety of your computer and begins this incredible journey across the globe.
Now your file doesn't just wander out onto the regular old internet. No way. Dropbox uses a really cool strategy called cold potato routing. The idea is simple. The public internet is like chaotic city traffic. It's slow, it's unpredictable, it's messy. Dropbox wants to get your data off that public road and onto its own private superhighway as fast as humanly possible. They've built these points of presence, or POPs, all over the world, which act like on-ramps. So no matter where you are, your file gets a fast pass onto this private network, ensuring your upload is super fast and super reliable.
After zipping across that private network, our file arrives. It's reached its destination, one of Dropbox's enormous custom-built data centers. The best way to picture this is like a digital library on an unimaginable scale. And this library really has two key parts. One part is the massive shelving for storing all the pages of all the books, and the other is the card catalog that tells you exactly where to find everything.
And the scale we're talking about here is just, it's hard to even wrap your head around. We're talking about storing and organizing the digital lives of over 700 million people. That's exabytes of data. When you get to that size, you can't just rent some servers from Amazon or Google. You literally have to invent your own solutions, from the silicon all the way up to the software. So let's start with the first part of that library, the bookshelves. Where do the actual ones and zeros, the bits and bytes of our file, actually get stored? Well, this is the job of a system that Dropbox built from scratch called Magic Pocket. Magic Pocket has this brilliant two-step move to keep your data safe. When your file first shows up, speed is everything, so it's instantly replicated. They make 3 full copies of it. Super fast, but also pretty expensive in terms of disk space. But then, a little while later, the system switches to a much more efficient method called erasure coding. This is the really clever part. It breaks your file into 10 data pieces and then creates 4 special parity pieces, and here's the magic. Any 4 of those 14 total pieces can get completely destroyed, a whole server can fail, and your file can still be perfectly rebuilt. It offers incredible durability while saving a ton of space.
Now, to make all of this storage economical, Dropbox decided to take on a massive hardware challenge. They use a special kind of hard drive called SMR. These drives get incredible storage density because they overlap the data tracks, kind of like the shingles on a roof. But there's a huge catch. Because they overlap, you can't just go back and change a little bit of data in the middle. You have to write everything in big, long, sequential chunks.
So, how did they solve this physical limitation? With incredibly smart software. Their Magic Pocket system was designed specifically to think like an SMR drive. First, it aggregates all the small incoming bits and pieces of files into a buffer. Then, it carefully sequences them into one massive continuous chunk. And finally, bam! It writes that entire blot to the drive in one perfect sequential operation. It is a textbook example of co-designing your software and hardware to work together perfectly.
Okay, so the actual contents of our file, the pages of the book, are stored safely. But what about everything else? The file's name, what folder it's in, who has permission to see it, all of that is metadata. If Magic Pocket is the library's shelves, metadata is the card catalog. It's the brains of the entire operation. See, in the early days, Dropbox stored all this metadata in what are called sharded databases. Basically, all of one user's info was stuck on one server. This created a huge, noisy neighbor problem. If one power user got super active, they could slow down the entire server for thousands of other people who happened to be on it. Not only that, but simple things like shared folders became a total nightmare because the data had to live on two different separate servers.
So, what did they do? They built their own solution, of course. It's a two-layer system called EdgeStore and Panda. And this custom-built database is completely flexible. It can automatically see when one part of the system is getting hot and just seamlessly move data around to balance the load with zero downtime. It turned a rigid, brittle system into one that's truly elastic.
So at this point, you'd think we're done, right? Our file is safely stored, its metadata is neatly cataloged, mission accomplished. But it's not even close. In fact, saving that one single file creates a ripple effect, kicking off a whole cascade of other jobs that need to get done.
And this whole cascade is managed by yet another custom system called CAPE. Think of CAPE as the behind-the-scenes orchestra conductor. Its entire job is to handle everything that needs to happen after your upload is safely confirmed. And this is so important because it lets that initial save feel instantaneous to you, while all the heavy lifting happens quietly in the background. So what kind of things does CAPE actually do? Well, it handles a ton of the magic that you just take for granted. You know, when you upload a photo and a little thumbnail preview appears? That's CAPE. When you can search for a word inside a PDF you just uploaded? Yep, CAPE again. It sends notifications to your other devices to start syncing, it runs malware scans, it updates audit logs. All of this is orchestrated by CAPE long after you've moved on to other things.
So let's just pull back for a second and look at the whole picture. We followed our file all the way from the desktop to the deepest corners of a data center. We've seen all the crazy background tasks it kicks off. So, what's the big takeaway here? What does it all mean?
Let's do a super quick recap of the whole journey. Step 1, our file is detected by Nucleus on your computer. Step 2, it's transmitted at high speed across Dropbox's private network. Step 3, it's stored for the long haul in Magic Pocket. Step 4, its info is indexed by EdgeStore. And step 5, it's processed by CAPE, kicking off that whole ripple effect. Every single step is handled by a custom-built system designed to solve a very specific problem at a scale that's almost impossible to comprehend.
And this really brings us to the core lesson, the fundamental philosophy of how Dropbox operates. The source material puts it perfectly. At the exabyte scale, software and hardware are no longer distinct. They must be co-designed. It means you can't just write some code and hope it runs well in whatever hardware you buy. No, you have to design the software with a deep, intimate understanding of the physical hardware it's going to run on, and vice versa. That tight integration, that's the real secret weapon.
So the next time you drag a file into that magic folder, maybe take half a second to appreciate the absolutely wild journey it's about to go on. And it really leaves me with one final question for you. What other simple apps do you use every single day that are probably hiding a similar world of invisible, incredible engineering?